Chapter 11, we're going to talk about gases. If you ever tried, when you were a kid, or actually some of us are still kids and we do crazy things like this, have you ever stuck a bunch of drinking straws together to make a really long straw? Did you ever try that? I remember trying to do stuff like this at a restaurant, waiting for the food to come, messing around with the orange soda, and Mom gets really ticked off. How long is too long when making a straw for drinking soda? Could you make one that was like super, super long? The answer is there is a limit to how long a straw could be. You ever wondered how a straw works? Well, you're sucking the liquid up, right? Well, how does that work? So inside the straw, there is air, right? There's air everywhere. So there's air in there. You remove some of the air molecules, and that decreases the pressure inside. The result is that the soda will move up in the straw. The reason that is, though, is because there's pressure from the atmosphere pressing down on the surface of the soda. And when the pressure in the straw is less than what's outside, the pressure outside pushes the soda up the straw against the force of gravity. So you feel like you're sucking the liquid up. Actually, what you're doing is you're lowering the pressure inside the straw, and the atmosphere is pushing the soda up into your mouth. So if you suck too hard, like, have you ever gotten a milkshake from Jack in the Box? Those things are really hard to get through the straw, right? You suck on the straw, and what happens to the straw? It collapses, right? It just goes flat because the milkshake is too thick. And they advertise that they're thick, and that's great and all, but if it's so thick you can't drink it, what good is it? Anyway, what if you had a really thick straw so that it wouldn't collapse? Could you then suck anything up an infinite distance? Well, it turns out that even if you had a perfect seal, because the thing with that straw that you're making in the restaurant is you're just sticking one inside the other and it leaks a little bit, right? So you could blame that on it not working. Even if there was no leak, it was one long, continuous piece, had rigid walls, maybe it was made out of stainless steel, right? So it's not going to collapse. You still could not suck soda up any further than about 34 feet. After that, doesn't matter how hard you suck, the liquid will not go up any farther. Does that seem strange? What is this arbitrary 34 feet business? Well, what's causing the soda to go up? It's the atmosphere pushing down. The atmosphere pushing down can only support a column of liquid that is a certain height. We've got gas molecules in the air that are bouncing around, and they collide with the surface of the liquid, and they cause a pressure. The pressure at sea level on our planet is, that's a crazy number, but this is more familiar, 14.7 pounds per square inch. Pound is a unit of force, square inch is an area. It's a force divided by an area. All of us are experiencing a pressure from the air around us of about 14.7 pounds per square inch. We don't feel that, though, because it's always there. You know, can you feel your t-shirt right now? Probably not. You put your clothes on, and after they've been on for a little bit, you don't notice them anymore, right? Your mind just kind of like, okay, that's normal, we'll just go on. We don't notice the air pressure because it's always there. But that pressure is there. So when you're sucking soda up into a straw, there's the atmospheric pressure pushing down on the soda. When the straw is open to the atmosphere, it has the same pressure, and we also have pressure pushing down in here. When you suck on the straw and lower the pressure, now you've got pressure going down on the outside of the straw, but inside that pressure is less because you've reduced pressure by sucking some of the air out. because this pressure is lower than the atmospheric pressure, pushes the soda up against gravity. How far the soda can be sucked up depends on the atmospheric pressure. So here we have not someone sucking, but a vacuum pump. And this vacuum pump is capable of creating basically a perfect vacuum. Here we have a rigid straw, if you will, really, really long. 34 feet is pretty tall, right? That's like about 4 humans tall. So if you attach a vacuum to this and pull a perfect vacuum on this, the soda goes up and you're like, yeah, we got this really long straw. And it gets up to about 10.3 meters and it won't go up any further. The pressure that the atmosphere exerts is 14.7 pounds per square inch. There's no pressure going down in here because it's a perfect vacuum. But there's another thing happening here, gravity. Gravity is also pulling on the soda. So gravity pulls on the soda, and we've got this pressure pushing up, but at some point it balances out. The weight, the force from gravity, is equal to the pressure exerted by the atmosphere on the outside, and so it won't rise any farther. Do any of you have, maybe you live outside the city limits and you have a pump for your water? You have a well instead of city water? No? You do? So outside the city, you have to pump the water out of the ground, right? And our water table's been falling, and so it's been a bit of a crisis. I know my mother-in-law had to replace her well, the pump in her well. She had to have a new well dug because her pump didn't get any water anymore. Like $22,000. But what are you going to do? You have to have water, right? So if water can only be pumped 34 feet, how do these wells work? The way they work, because a lot of them have to be like 100, 200 feet deep now. The pump is not at the surface. The pump is lowered deep into the well. The pump has to be within 34 feet of the surface of the water, or it cannot pump any water.